let's start. Hello, everyone. I'm really excited and I'm really happy to see so many people here. First of all, thank you for coming and thank you for choosing this session. I really hope that it will be insightful and useful for you. And you are probably familiar with that time of the late autumn when merchants offer great deals and discounts. And I want to share personal stories that happened to me back in 2022. So, long story short, I was excited about one specific advent calendar, but when I finally decided to make a purchase, it had already been sold out everywhere. But then the miracle happened. It was Black Friday. It was a great offer from the brand and the advent calendar available online, of course. So at that time, I made a purchase. I had received a confirmation that my payment had been successfully completed. And I also even received an email that the package had already been shipped and was on its way to me. So really, really excited. And then 1 more week later, instead of my package, I finally got this email about refund. And yeah, now I can of course joke about this, but at that time I was really, really upset. And all upset feelings apart, I clearly understood that it definitely was a technical issue which could be prevented and completely avoided. And avoidance of it could of course keep me as a customer for that brand for the future purchases. So again, hello everyone. My name is Kristina Derechei. I'm a software engineer from Klarna, and I'm working in a payments API team. We are building business solutions to add Klarna as a payment method to checkout, to initiate a payment, and also to place an order. And today I want to share my experience as a backend engineer on how to build resilient services and how to be continuously ready with quality and optimized cost. So, Klarna. Klarna is an established payments network and shopping ecosystem with the goal to become the first AI-powered financial assistant. We were established in 2005 and have become a fully licensed bank since 2017. Klarna partnered with the biggest brands, serving the best consumers who love and trust us, and we're also backed by the world-leading investors. Our mission is to accelerate trade by providing real value for consumers and merchants. So we are helping consumers save their time and money, and we are also helping merchants grow their businesses. And Klarna serves 150 million consumers in more than 45 countries, and we are processing more than 2 million transactions every day. And being ready to handle these many transactions requires our services to be ready to cope with the load, but most importantly, to do this in an efficient way. Because people rely on us and people expect their orders to be successfully completed. And this is why we have to always be prepared. Because on the other hand, building an unreliable service results in financial losses, but also in losing the most important currency, trust. So Klarna is a big company, and we reached this point because everyone expects us to just work, and this is what we do. And business side is, of course, one important part, but another important part is actually us, software engineers who build the systems. Because as system owners, we should always strive to know the most about our systems. And when we start to dive deep into the system details behavior, we might ask ourselves different questions, like how does the system behave when it receives a spike of load? And for example, what are our limits? Can we handle 100 requests per second? Or maybe can we handle 1,000 requests per second? And these and many other important questions might arise when we start to deeply investigate the system behavior. And another important part, it's last here but not least, it's the cost optimization. Because it is always important to identify the areas which could be optimized and take the required steps. For example, when we expect an increase in load, we could, of course, scale our instances horizontally to be able to absorb the load, or we could scale the database vertically, but again, here we are jumping back to the question of resource usage and operational cost optimization. So we could, of course, scale up to 100 instances or probably use the most efficient database, but does it really worth it? Do we really need that many machines or that efficient database? So let's figure out how we find answers to all of these questions at Klarna while building our resilient services in our continuous readiness journey. And at Klarna company level, there is a whole process to ensure that each team, each service can handle the load efficiently. We always identify all critical passes, and involved teams are contacted ahead. And it is also worth mentioning that we are using the same set of guidelines, timelines, and tools to minimize effort we are spending for configuring our performance testing environments. So today we will discuss the key topics essential for achieving both operational efficiency and continuous readiness. And the first point is actually what exactly should be prepared. And the bare minimum that should be prepared, it is the application layer, the database layer, and the alerts. This list could, of course, be extended, but this is the minimum that should always be ready. So we, of course, need to ensure that the application can handle the load efficiently, but, usually the database always plays a critical role in the software architecture. And in many cases, the outage of the database might mean the complete unavailability of the application. And it is also alerts, because we would like to be proactive, and we want to be able to make the required steps when our systems start to degrade, and also we should be able to notice this. And talking about application. Applications that handle the load efficiently is better positioned to maintain a great user experience, to achieve scalability, and also to have a positive business reputation. And the best way to achieve all of this is to run performance tests and simulate the load on an application. And the performance tests, they should have the real case scenarios, and the environment should be really close to the production one. And the same setup, which should have the performance environment, it means the same number and type of instances, same database settings, and also it is vital that the database storage used in test database is similar or same as in production one. We will talk about this a bit later. Also, same environment configurations and, of course, representative data. And, most likely any service has external and internal dependencies, and the performance of the dependencies is something that you could have little direct control over, right? But usually this performance, it plays a crucial role in the smooth customer experience. So here we're jumping to the point of the cooperation and communication with your dependencies, because sometimes, if not always, the negative impact of the incorrect behavior of the dependency could be prevented and completely avoided for the customer. So, though performance testing of the happy flow is vital, it is also crucial to understand how the system behaves given the failure of the dependency. And the best cost-efficient and independent way to do this is to actually mock the misbehavior of the dependencies, as well as behavior. But to do so, in my team, we are using the YMock tool. So it is pretty straightforward, really easy to set up. It can run as a standalone process, but most importantly, it has a variety of nice features, which we are heavily using in my team. So such features are HTTP response stabbing, matchable on URL and header and body content patterns, also response time configuration and fault injection. And all these features, they allow us to build really complex scenarios and to simulate really complex process of misbehavior of our dependencies. And it is worth mentioning that in the YMock terminology, the scenario is basically a state machine. So when we jump from one scenario to another scenario, we are doing this just from command line without the need of redeployment. So when we need to simulate the huge delay from a dependency, or probably the error response from a dependency, we are doing all of this without the redeployment, and then we're returning it back to the normal state. And I want to mention that when we were testing our misbehavior of our dependencies, we noticed that when one of our critical dependencies was misbehaving, in one specific way, it actually led to some exceptions on our side. And in order to fix that, we introduced the circuit breaker patterns with read-writes, activating fallbacks mechanisms wherever possible. I will briefly describe what the circuit breaker pattern is. It's a design pattern which is used to prevent failure propagation. And the circuit breaker pattern, design pattern, it was inspired by an electrical circuit breaker, which is used to, which actually it blocks the flow of the electricity if failure occurs, and it prevents the further damage. And in the context of software engineering, the circuit breaker, what it does, it moves to an open state, which means that it blocks all the further requests to a dependency, which is misbehaving, and it allows the dependency to recover, and also it improves the resiliency of the application itself. And one important note from us is that always pay attention to the sliding window setting when you configure your circuit breakers. So the sliding window setting, it is used to determine the window which calculates the number of errors or correct behavior, and then it is used in the decision-making process of the circuit breaker. So in case the sliding window calculating the errors is too small, it might happen that the circuit breaker will open too soon, which is also an unwanted behavior as well. So some key takeaways from this part. First of all, always test your system in isolation and use mocks to simulate the behavior and misbehavior from the system. Communicate with your dependencies. So ask about latencies and always inform your dependencies when your system expects an increase in load, so they can prepare their services as well. Perform the analysis of the past performance or degradation of the dependencies, and based on the analysis, you could always implement fallbacks, set timeouts, and some fixes. And you know that when performance environment is configured, application is set up, mocks are in place, it might be a good time to start the performance tests, but not yet. So here we are jumping to the critical point in the continuous readiness process. It is a test data preparation. So using the relevant and representative test data ensures that the test environment mirrors the actual production environment. And realistic test data, they allow to more accurately analyze the response time of application, also to actually understand how the application reacts to the different user interactions, to the different user data, different complexity of data, and it helps to identify possible bottlenecks. So we always aim to have the same test data, the same amount of test data which we actually expect to receive in production. And on the other hand, using the small set of test data will only test the caching solutions on different layers of your application. So the small set of test data will skew indexes, storage plans, caching mechanisms again, but most importantly, it might provide inaccurate results. So in my team, what we are doing is we are using the test data randomization. So we always randomize the test data to ensure that we are not testing our cache. We also always analyze all possible user flows to be able to cover them in the scenarios. And we also ensure that we can generate the same amount of test data that we expect to have in production. And you know that test data, it of course influences the load on application. But most importantly is that test data, correct test data, also influences the load on a database, and it allows to understand how the database itself behaves under the different data volumes. So let's jump into the database layer preparation part. And you know, databases, they are often considered the backbone of the application, right? And therefore, they should be set up, operated, and managed in the most secure and compliant manner. And one thing which we definitely want to avoid is the complete outage of the database, because in many cases, it might mean the complete unavailability of whole application. And here are some rules that we follow in my team when we configure our databases. So first of all, always configure a standby instance with read replicas in a separate availability zone to increase the availability of an application. So in case something is happening in one availability zone, you could easily switch to a standby instance in another availability zone and therefore improve the performance of the application. Next point is monitoring. So we all probably know the rule where the less is more, but it is not related to monitoring at all. So the rule of thumb which we use in my team is to monitor as much as possible, and each metric matters. The CPU, the number of active connections, all of this helps us to correctly identify the state of database and its behavior. Next point is backups. So backups are a must-have, and we always configure a backup, but it is also a suggestion to always configure a backup, but hopefully you will never have a reason to use them, right? Because sometimes recovering from a backup might take really a lot of time depending on the database size. So it is always better to act in advance than to react under pressure. Next point is storage auto-scaling. So always configure the storage auto-scaling by default, unless it's already configured like in Aurora cluster, but the idea is that we want to avoid manual intervention when the load increases. So it should be handled by database itself. And the last point is the connection pool. So connection pool, which manages a set of open connection from an application to a database. It is always better and it always helps to improve the overall performance of the application because you do not need to manage the open connection by yourself. Therefore, you could take some existing like open libraries or implement connection pool yourself. And talking a bit more about connection pools. So, you know, in software engineering, sometimes people say that, hey, we can scale our services up to infinity, and we could have the whatever number of instances we want. And unfortunately, this is not a complete truth if there is a database layer. So as soon as we have the database layer, we always must ensure that the application is not trying to generate more connections than the database can handle, because this will definitely lead to some errors on the client side, right? So to handle this in my team, we are using two variables always. So when we configure our connection pools, what we are doing is that we always know the maximum allowed number of connections on a database layer, and we always know the number of maximum instances to which our application might scale. So depending on these variables, we always reconfigure and recalculate the number of all possible connections in the maximum connections, in the connection pools. So for example, when we understand that the application should scale and should have more instances than it have right now, we will always recalculate the connection pools. And another important aspect of database is cost. And you know, in each team, there might be a situation when the data volume grows or the load increases and team is considering to scale the database vertically up, which usually means the increase in cost. But the suggestion is do not hesitate to test different instance classes, because sometimes the lower instance class might perform exactly the same as the higher instance type, depending on the use case and depending on the type of the application. So there, of course, could be a lot of cases where vertical scale-up is really required, but sometimes implementing few features and performing some enhancements to an existing layer could prevent the vertical scale-up and therefore could show a good cost optimization. And the one feature which I want to discuss is having an arbitrary number of databases. And this is the feature which we use and we love, I could say, in my team a lot. So depending on the instance classes which you are considering, having several databases but with smaller instance class might perform exactly the same but be more cost efficient than one database but with higher instance class. And in overall, this feature of having arbitrary number of database, it helps our team a lot and gives our team like a lot of flexibility and a lot of scalability. So we could quickly accommodate to varying requirements. But also this feature allows us with just one deployment connect to any number of databases in any environment, and therefore we could very easily scale our application, right? Make it more available and be ready to handle the increased load. Also, an arbitrary number of databases allows us to perform database rotation without any impact on customers and with zero downtime, which is also very precious. So consider adding this functionality to your code base as one of course, many possible improvements which could be done to improve the database layer. And some more enhancements that could be done, and this is what we are doing. So first of all, always keep the database engine version up to date. We are doing this to get the latest optimizations from the platform. Also, optimize the database queries. Again, there are a lot of ways to optimize existing queries, like ensure that if there is a pagination, you use limits, or for example, ensure that you are not selecting all the columns from the table, but you just the required ones, etc. There are a lot of ways to improve them. And the suggestion is to spend some time and do these optimizations before scaling the database vertically. And another thing, of course, it's indexes. You know that, again, indexes, we all know about them, but despite the creating new ones, it is always important to revisit existing ones and remove the indexes which are not in use anymore. And it is worth mentioning that database tests, they are quite specific because they require that the storage used in the test database is similar or same as the storage used in the production database. So consistency is key when performing the performance tests. And when the configurations or storages differ, this might mean that the tests are not reliable, and having the storage used in the test database allows us to perform the correct capacity planning, and therefore we avoid over or underestimating, because we always know how the database will behave. And another critical aspect in ensuring database resiliency is failover testing. So downtime, unfortunately, is unavoidable during any given failover, but depending on the engine version which you are using and depending on the actual implementation, the failover might be handled really well. So, for example, usually if your application is read heavy, usually, again, depending on the implementation and engine version, but read transactions will go to the reader node without any issues. And what it might mean is that the failover might be even not noticeable for the end customers. But sometimes the write transactions, they might fail, again, depending on implementation. And our goal is to ensure that the application can handle the failover gracefully. And here I want to share the failover example from my team. So what is on the screen? We have configured 3 databases, and each area which you could see on the screen, it represents only write transactions. So overall, this graph represents number of write transactions that our application was able to handle. And you may see there are some drop downs, and in the dark blue and pink area, and these drop downs, they represent actually the failover cases. And what we wanted to see here is that our application, you see that overall number of transactions is not decreased at all. And what we want to see here is that the application was able to handle the failover without the need of redeployment, and it wasn't crashed completely. So with sufficient retry mechanisms, exponential backoffs, and solid exception handling, the failover could be handled very gracefully. And talking more about retries. So one cannot just indefinitely retry the transactions, nor does it make sense to retry the transactions which are guaranteed to fail upon retry. But in case there is a failover, we could identify a list of possible failovers, and we could retry the transactions which failed only because of these exceptions. So such errors could be connection checkout errors, connection closed errors, socket closed, and some others, of course. But the thing here is that when you identify a list of possible exceptions that say that, okay, it is failover happening, then you can retry the transactions and therefore improve the performance of the end user, right? So you do not lose the transactions. But be careful when retrying. Because if the system on the other side is returning errors because it is overloaded, retries might solve no issue, but actually bring some more problems. And here we are jumping back to the exponential backoff. So once you have retries in place, you do not want to continue blasting through your retries in a matter of milliseconds. Because if the transaction failed and you are executing retry almost immediately, it will likely fail again. So what we are achieving is, when we introduce exponential backoff, what we are achieving is that we are adding some delays, which is growing with each retry, but these delays allows the system, in our case database, but it could be implemented to any other part. It allows the system on the other side to recover. And therefore, we improve both the application resiliency, but we are also not overloading the remote service. And to finish the technical preparation part of the presentation, I just want to introduce some enhancements which you could do right away and therefore improve the resiliency of your application. So the rule of thumb, timeouts. Always set up timeouts wherever it is possible. And the minimum here is connection pools. So connection pools, they usually have a setting to determine on how long a client would wait to get a connection from a connection pool. And assuming there is a situation when all connections are in use and it is not possible to get a connection from a connection pool, it is always better to fail fast in this case instead of queuing the clients and therefore instead of creating even more load on your service and your resources. Next point is the database queries. So having the database timeouts, having the timeouts on database queries, it helps to prevent long-running queries on a database layer, and therefore it will improve the performance of a database. And depending on your application, it might be worth considering adding a timeouts on a per query basis. But here again, please always remember that queries which operate on an index lookups, they are much faster than queries which operate on a non-index lookups. So keep this in mind when you set the timeouts. And the last point, it's HTTP client. So again, it is always better to set a timeout and to activate a fallback when the dependency is misbehaving. So you could activate the fallback earlier than later, and therefore your clients would not wait like 4 minutes to get a response from a dependency. And the next quick enhancement could be done to the resource usage. So talking about login. If your application logs a lot, there might be a situation when an application is flooded up with requests. It might spend a lot of resources to handle the requests. But again, if the application logs a lot, it might happen that the application will spend a lot of resources while handling the incoming requests and also while handling the logs. So this could be easily fixed by introducing asynchronous login versus synchronous. And the last point is disk space usage. So if you're logging to a file, consider log file rotation sooner than later to avoid running out of disk space. And let's shift our focus into another area of continuous readiness. It's monitoring and alerting. So some of the reasons we want to have a reliable monitoring in my team is that we want to ensure that availability can be measured and achieved. We also want to perform quick diagnosis and quick incident management in case something happens. We also want to analyze long-term trends and to be able to correlate the events, like whether the number of 500s just spiked or whether there was a release during the same time. And here is another point where the rule less is more is not working, unfortunately, but here we need to monitor, the suggestion is to monitor as much as possible. So the CPU, active connections, active threads, and some complex business metrics, of course, they all help to piece together some possible causes and effects. And in my team, we actually, as I have already said, we monitor really a lot, and we have really a lot of different dashboards. And what we actually did, we created a document where we put all of our dashboard, we categorize them and organize them. And we shared this list with all the engineers and all the people actually in Klarna. So when anyone wants to check how our system behaves, anyone could open the document and find the dashboard or monitor in which person might be interested. And it's also possible to check whether our system is alerting or not. And talking more about alerts, we want to reserve alerts to the situations that are actionable by the person receiving the alert, and we also want to reduce the number of false positive alerts and alerts that send the exact same message to the exact same event. And here, we are jumping to the point that having the same monitors and alerts configured for production and performance environment are vital, and let me describe why. So during our performance tests, we generate the kind of traffic that we would expect to have in production. So we want to check how it affected our monitors, right? But we also want to check how it affected our alerts. And the thing here is that during our performance tests, in my team, we sometimes intentionally generate the misbehavior of our system. So we are tracking when and which alerts are sent. So this exercise, it helps us a lot to identify how our alerting system actually works. And what we want to achieve is that we want to ensure that we are receiving the alert at that time when we actually expected to receive. And during this exercise, we revisit our existing alerts and we are creating new ones, updating existing ones, etc. So I really suggest to test alerts and to intentionally simulate the misbehavior of your system. So some key takeaways. Again, all relevant metrics matter, so monitor as much as possible and you would be able to put together causes and effects and to quickly perform the incident management in case it happens. Again, always test your alerts. So intentionally simulate the behavior where you could understand which and when the alert is triggered. And yeah, I'm sorry I didn't mention that, but in case you are just considering to add monitoring to your system, and in case your system exposes a HTTP API, the good starting point for monitoring is the red method. So monitor request rate, error rate, and duration. This is a good starting point, but it can show a great system health information. And you know that having the best possible monitoring and alerting systems configured, unfortunately does not completely prevent the possible incidents that might happen. And however, the way team handles the incidents, it matters really a lot. So imagine a situation when the system starts to degrade. You, for example, definitely see a number of errors growing up or number of transactions going down. And assume there is a situation that you really know how to fix the issue, but for example, Jenkins or other systems that you're using for deploy is not working and you just can't remember the command. It's something, I don't know, might happen, right? Or for example, assume that you know the system which is misbehaving and you know how to perform fix there, but you just do not have access. And many other cases that could happen, right? And the solution here is the runbook. So the runbooks, it provides your team with the knowledge and confidence which is needed to recover from an unplanned outages. And having a step-by-step list of instructions, guidelines, logs, queries, which are very useful, it actually helps a lot to the person which is handling the incident, and it also helps a lot for the team to, for example, reduce the burden when faced with such incidents. But most importantly, such documents helps a lot to increase the response, to decrease the response. I mean, you can handle the incidents better because you just have all the commands which you need to execute and you can just do them instead of spending time for searching them. So always think reactively on what should be included. The questions which might be useful, for example, what are the largest incidents that happened and how the team could handle them more efficiently. Always document the finding outs, always document the answers, and in case something similar happens, you will have already have a step-by-step guide, step-by-step instructions, and we will handle the incident more gracefully. And also always be precise, because unfortunately ambiguity only works to slow things down, and this is a place where the devil is in detail. So document as much as possible, and even something seems super obvious to you right now, this might not seem super obvious for you when you are handling the incident. So put yourself in an on-call mind and provide as much of details as you might want when you are handling the incident. And again, if you need to log in anywhere, so the suggestion that if you're not working with the system right now, but you might work with it later, or you probably might know the system, right? Always check that you have the required access and permissions, which you might possibly need to have to perform the fixes. Again, jumping back to the deployment process. Sometimes some teams do not have permissions to make the deployment from their local machines. So this is something that you might want to consider in case Jenkins is not working, etc., etc. So something like this. And the final part of the presentation, it is the testing process itself. So to build a reliable system, it means to understand how it behaves during different types of load. And the best way to do this is to simulate this load and to see how the system is behaving. And here I just want to tell you again that I'm a software engineer and my team, it's mostly software engineers. So we are working, our day-to-day job is around building the code and not building the test. So which I'm presenting here, you of course might have some great solutions, and if you're a test engineer, it of course might be better, but here I'm just presenting my experience, and I hope it will be useful and inspiring for you. So the first test that we are running on a day-to-day basis, it's not every day of course, but it's a routine, it's a target capacity load test. So the goal of the test is to check how the system absorbs the load, and also to understand that the capacity was planned correctly. So the thing here, what we want to achieve is that we want to see that system is able to successfully handle the load without the need of scaling up, without obviously errors, and without some unexpected behavior, so that the fallbacks are not activated when we do not expect that. So what we are doing during this test? So during this test, we gradually increase the load until we reach the number of transactions per time unit. Let me just show you an example. So we gradually increase the load until we just reach the transactions per time unit. And my team, we usually talk about requests per second, but okay, it can be different for your case as well. And when we reach the load, what we want to do, we want to maintain the load for some meaningful amount of time. And in our case, it usually the minimum is 2 hours, because this amount of time allows us to get the meaningful test results and to understand how the system behaves. So I have only this graph here because this is a very basic test, and you can see we gradually increase the load, maintained it, and what we definitely do not want to see here is that we do not want to see some scaling up, we do not want to see any errors, any issues at all. So basically the CPU should be stable and system should be stable itself. And based on these test results, we understand which database, which number of instances, which resources should be used, and we can plan our capacity accordingly. The next test is the robustness test. So we briefly described it already. So the robustness test, it evaluates how the system reacts under challenging conditions. This could be different conditions, and just an example again, the dependency misbehavior could be. And we simulate different scenarios like delays, complete outage, error responses, etc. And it allows to understand where are there any vulnerabilities or weaknesses in our system. So what we're doing is we put our system under a steady state load, and we simulate the different unexpected scenarios. So here you can see one of the examples. You can see some decrease in handled transactions. So what happened during this time? During this time, we intentionally simulated the very huge delay from one of our critical dependency. But this delay was not higher than the timeout and the communicated timeout. So it was really, really close, but it was never higher. And the thing here is that all the requests that we were sending to that system, all of them were very, very delayed. And our system had to wait to get a response because the delay was within the expected amount of time. So what we want to check here, we checked here that our system will still be able to process the transactions, and we do not want to see any errors or like zero process transactions. And next test is a stress test. So a stress test, it's a type of testing which evaluates how a system behaves while putting it into critical conditions and extreme conditions. So these tests, in our case, we use to determine how what is the limits of our system. So at which number of transactions per second, for example, our system starts to degrade, or at which level of database our operations, the database latency increases. And here is one example of this test. So each line, which you can see on the screen, it represents a separate instance. So we were putting our system into really, really challenging conditions. And during this test, we actually was able to find out at which level of requests per second our system started to scale up again and again in order to be able to successfully absorb the load. And when we know this limitation, we now know which optimizations could be done, of course, to increase the limitation and run the test again. The next test is spike test. I will be very quick here. So we want to ensure that the system is able to handle the spikes of requests gracefully. And the thing here is that sometimes spikes of requests, they usually happen within the milliseconds. And if you have an automatic scale up, this might mean that spike will happen faster than the automatic scale up will jump in. So what we are checking during this test is that our system is able to handle the load without the need of scaling up additional resources, because we definitely want to avoid that, right? So as you might see, this is an example of spike test, and the spike test could happen like really, really quickly. And what we are ensuring is that, again, no exceptions, no errors, but also no scale up, as for example, you saw on the previous slide. And the last point, it's the deployment during peak. So you know that deployment during peak, I mean, in each team, it could be done only when the incident with high severity is happening. And the possibility of this to happen is near zero. But we want and we aim to be able to handle even this situation. We do not expect it to happen, of course, but we should be prepared always. So my team uses a canary deployment strategy. So this is a deployment strategy when at the same time we have two sets of instances. One with current applications that we are running in production, another set of instances with a new version. So for some time we just route the part of the traffic from the current production version to the new version, and we just monitor that everything works as expected. But the thing here is that at the same time, we have the exact amount of instances, right? The amount of instances, it doubles. And assuming that there is a peak load, right? And we need to perform a deployment with some fixes. This is just a theoretical case. So there might be a situation when the current production version, and the current version is using almost all configured connections from a connection pool. And assuming that there is such situation and we perform the deployment, during deployment, probably the load is so huge that the new instances, they start to have such a huge load that they also use almost all configured resources, right? Configured connections from a connection pool. And in this case, what might happen is that we're actually doubling the load on our database, and we might overload it like completely. And one possible way to handle this is to, we talked briefly about the configuration for connection pool, but what could be done is to use only 50% of allowed connections on the database layer. So as soon as you have the allowed number of connections, maximum on a database layer, and you know the maximum number of applications, you could take that into account, but you could aim to use only 50% of that when you configure the connection pool. Therefore, you probably could be prepared to handle even this disruptive situation very gracefully. So to sum up, first of all, thank you again for coming and thank you for listening. And I just want to say that continuous readiness is not just a best practice. It becomes a requirement for almost all the services. And I hope this session and all the points that we have discussed today, they are useful for you and you could add them to your systems right away. Thank you so much. Any questions you might have? Of course.
Are you using any chaos engineering to do the robustness tests?
Yeah, I will repeat the question, so it will be on the video as well. So the question is whether we are using any chaos engineering for our robustness tests, and yes, we do, but we are using also something like toxiproxy for during our not the performance tests, but during our like end-to-end tests. But yeah, this is one of the possible steps, and thank you for mentioning this. Thank you. Any other questions? Of course. So what are we using for mocking the dependencies? To mock the dependencies in the during the performance test or during the performance test we use the wire mock. Yeah. Any other questions? Yeah, please do not hesitate to contact me or find me near the Klarna stand or contact me via LinkedIn if you have something else. I will be happy to answer, of course. Thank you.